In this lecture, I would like to discuss about the examples of different types of the point groups. In the previous lecture, we has been discussed how the point group it is assigned to the molecule. We know that point group is the collection of all the symmetry elements and symmetry operations which are present in the molecule. A molecule is having different kinds of the symmetry elements. So collection of all that symmetry elements by certain rules, the specific point group is given to the molecule. Now let us take the examples of the point group. First type of the point group, it is C type. So when C infinity V point group is given, the example it is here the hydrogen chloride molecule. So you can see here the structure of hydrogen chloride molecule. It is a linear molecule. We know that chlorine is a more electronegative element and hydrogen is less electronegative element, and there exists a covalent bond between the hydrogen and chlorine atom. So this figure shows that this is the principal axis that is said. Now what is the order of the axis? What is the order of the axis? Now suppose that hydrogen atom, it is now the spherical. It is having the spherical shape. This is the hydrogen atom. Chlorine atom. So the chlorine atom, it is also spherical. So when we are passing a line here and rotating this, suppose that it is a principal axis. Now even though we are rotating it at a very small minute position, suppose hydrogen atom it is a ball like, you can take the example of the dumbbell. So in a dumbbell, when you are rotating, you are getting the equivalent configuration at any angle. If you are rotating, just rotating by 1 degree, 0.5 degree, then you are getting the equivalent configuration of that. So what is the order of axis? It is infinity order of axis. Axis of rotation, it is infinity. At any angle, if you are rotating, even though at 1 degree or 2 degree or 1.5 degree, then you are getting the same equivalent orientation of this hydrogen chloride molecule. So the order of axis, it is infinity. N, it is equal to infinity here. Number of times we can rotate this water molecule. Number of times we can rotate this HCl molecule. So it is having C infinity, that is the principal axis. Now this is the C infinity is the principal axis here. So we find out the first symmetry element which is present in the HCl molecule. Now this molecule is also having number of vertical number of mirror planes, and that number of mirror planes are equal to infinity sigma v. It is not having only one vertical mirror plane, two vertical mirror plane, but it is having infinity vertical mirror planes. So it means that the HCl molecule is having infinity sigma v. Number of mirror planes we can passing through this. Okay, through this point, passing the mirror plane here at this position, at this position, at this position. Okay, then it is having the infinity sigma v, and identity is always there. So these are the symmetry elements which are present in the HCl molecule. So as it is having the C infinity principal axis and infinity sigma v mirror planes are existing there, So the point group assigned to the HCl molecule, it is C infinity V. That is the point group of the HCl molecule, C infinity V. So generally, the linear type of the molecules, for example, HCl, SCO, they are having such type of the point group C infinity V. C infinity V, because this point group contains C infinity axis and sigma V plane of the symmetry. So in HCl molecule, there are infinite fold rotation axis. Rotation axis, it is infinite fold, and infinite number of the vertical planes the molecule is showing. Therefore, the point group assigned to the HCl molecule, it is C infinity V. Now let us take another example belongs to this C2V point group. C2V point group, C type of the point group. The very good example, it is given here, the water molecule. So this is the structure of the water molecule. The structure of the water molecule, it is shown here. It is having the angular shape. Now the vertical line, it is passing through the oxygen atom. So if we are rotating that along that vertical line by the angle of, by the 180 degree angle of rotation, it is 180 degree, then we are getting the equivalent orientation. So that orientation will be like this. Hydrogen 2 will be here, hydrogen 1 will be here. So thus the water molecule is having C2 axis, and that is the principal axis. C2 axis, it is the principal axis here. It means that water molecule is having two-fold axis of the symmetry. So C2 is existing there. Along with the C2, there are two vertical mirror planes. So you can see here, this is one vertical mirror plane, and this is the one vertical mirror plane. So two vertical mirror planes are existing there. We can show that symmetric operation in this way. Vertical mirror planes, the symmetry operation can be shown. So when we are passing the vertical mirror plane through the water molecule, it will be lies here, vertical mirror plane like this. One mirror plane will be like this, as it has been shown here. This is the mirror plane. So this hydrogen will be here and this hydrogen will be here. In the mirror plane, we can see the image and it will be like this. So equivalent orientation, hydrogen atom 2 is here and hydrogen atom is here in the mirror plane. In the mirror plane, this will now come first, and hydrogen atom 1 go back. Okay, and it is having the two vertical mirror planes where in one mirror plane all the atoms are lies. Okay. So the water molecule is having two vertical mirror planes. So number of symmetric operations or number of symmetry elements in the water molecule becomes equal to C2, then two vertical mirror planes, and it is having identity. Identity is existing in all the molecules. When we rotate the water molecule through 360 degree, we are getting the identical configuration. So it means that it is having the identity symmetry element. Okay. So in water molecule, proper axis is C2 axis. It has two vertical mirror planes, 2 sigma b. That is a molecular plane and plane passing through the oxygen atom. This is the plane passing through the oxygen atom. Another plane, it is a molecular plane where all the atoms are lies. Okay. So the point group assigned to the water molecule, collection of these symmetry elements. So principal axis, it is C2, vertical. So C2V, it is the point group to the water molecule. Then third type of the third example of this C type of the point group, it is C3V point group. The example, it is ammonia molecule. So ammonia molecule is having C3V type of the point group. So you can see here the structure of the ammonia molecule. So this is the structure of the ammonia molecule. You can see here nitrogen and 3 hydrogen atoms are covalently bonded. It is a pyramid like of the shape. Angle between nitrogen, hydrogen, hydrogen, it is around 120 degree here. It is around 120 degree. So when we are passing this principal axis through nitrogen atom, when we are passing the principal axis through nitrogen atom, so this is the principal axis here, z axis, and we are rotating this. What happens? The hydrogen atoms are changing their position. So we can show first theta it is equal to here 120 degree. So what happens here? The hydrogen atom, suppose it is anti-clockwise rotation as it has seen here. So hydrogen atom 2 will be here. So we can show the structure in this way. The equivalent configuration can be shown in this way. So here the hydrogen atom 2 will be here. Hydrogen atom 1 will be here. Anti-clockwise rotation, and no, sorry, hydrogen atom 3 is here, and hydrogen 2 is here, and hydrogen 1 will be here. Okay. So in this way, we are getting the equivalent configuration here. Equivalent configuration is here. This is hydrogen 1. Okay, 1, 2, and 3. So it means that ammonia molecule is having theta equal to 120 degrees. So n it is equal to twice pi upon theta. So it is equal to 360 divided by 120. It is equal to 3. Order of axis is 3. So NH3 molecule has C3 axis. Not only it is having the C3 axis, but it is having the 3 sigma V mirror planes. 3 sigma V. The possible symmetric operations are, it is having C31, C32, 3 sigma V and identity. It is having, so the principal axis is C3 axis, which is passes through the nitrogen atom, and the center of the triangle, it is passing through the nitrogen atom, and this is a triangle here. You can see this is a triangle. It is passing through the principal axis, having hydrogen atom at the corners. These hydrogen atoms at the corner of the triangles. Okay. Then it has 3 vertical planes of symmetry. Each plane passes through the nitrogen and one of the 3 hydrogen atoms. Each plane it is passing through the nitrogen and one of the 3 hydrogen atoms. So this diagram is shown here. So you can see here the vertical plane, it is passing through the nitrogen atom and one of the hydrogen atoms. So this is one vertical plane, this is second, this is third. So diagram can be shown in this way. So thus ammonia molecule is having symmetry operations C31, C32, 3 sigma V E. So principal axis is C3. Hence the point group assigned to the ammonia molecule, it is point group assigned to the ammonia molecule, it is C3V, as it is having the 3 vertical mirror planes. This is first, this is second, and this is third. So thus point group assigned to the water molecule, point group assigned to the ammonia molecule, it is C3V. So in this way we discuss in this lecture the type of the point groups and examples of the point groups, particularly C type of the point groups.